Hey, what's up, fam? Welcome back. Y'all ready to dive into some seriously lit geometry today?
Geometry and lit in the same sentence? Whoa. Who? Okay, this is going to be interesting.
Oh, trust me, it's gonna be fire. We're tackling right pyramids.
Oh, yeah?
You know, those pointy structures that just scream SAT math problems.
Ah, those. Not gonna lie, they had me shook back in the day.
For real. But the good news is, once you crack the code, they're actually low-key predictable.
So you're saying they're not just, random torture devices designed to make us sweat?
Exactly. We've got some dope tips from this study guide that'll break them down step by step.
Bet. So what's the game plan for today's deep dive?
Simple. We're gonna arm you with all the formulas, tricks, and strategies you need to conquer these pyramid problems like a boss.
And maybe even learn to appreciate their beauty along the way?
High key, yeah. And who knows? You might even find yourself using this stuff in real life.
Like designing a pyramid-shaped treehouse? Okay, maybe not, but you never know.
Alright, first things first, formulas. What are the essentials we need to know to even begin tackling these problems?
Alright, there are two big ones. First up, we've got the volume formula. It tells you how much space the pyramid takes up.
Hit me with it.
It's V equals 1/3 times B times H.
V equals 1/3 BH. Got it. But, what do those letters stand for again?
V is volume, obviously. B is the area of the base. And H is the height of the pyramid.
Ah, makes sense. So basically, we're finding the area of the bottom and multiplying it by the height, but with a little 1/3 twist.
Exactly. And that 1/3 can trip people up, but here's the tea. Think of a cube with the same base and height as your pyramid.
Whoa, big brain moment.
Right? The pyramid only takes up 1/3 of that space.
Never thought of it like that. Mind blown.
See? Math can be cool.
Okay, so volume, check. What's the other crucial formula?
Next up is the total surface area, or TSA. It tells you the total area of all the pyramid's faces combined.
Oh, so if we were gonna paint the whole thing, we'd need the TSA to know how much paint to buy.
Exactly, you're catching on.
Sweet. So what's the formula?
TSA equals B plus 1/2 times P times L.
TSA equals B plus 1/2 PL. Noted. But what's P and L?
P is the perimeter of the base, so the total length around it.
Gotcha.
And L is the slant height, the distance from the tip down the middle of a face to the base edge.
Ah, gotcha. So we've got our two key formulas.
Yep.
Now, how do we actually use them when we're faced with a real problem?
Time for some practice.
Oh, yes.
Let's imagine we have a pyramid with a square base, each side measuring 8 centimeters, and a height of 6 centimeters.
Okay, 8 centimeters base, 6 centimeters height. I'm with you.
How do we find its volume?
Alright, so V equals 1/3 BH.
Exactly.
Height is 6, so H is 6. But what's B?
Since it's a square base, area is side times side.
So 8 times 8 equals 64 square centimeters.
You got it.
Bet. So plug it in. V equals 1/3 times 64 times 6.
And what's that give us?
1/3 times 64 times 6. Let's see. That equals 128 cubic centimeters.
Boom! Nailed it.
Nice. Feeling more confident already.
Let's keep the momentum going.
Absolutely.
How about we try one with surface area?
Bring it on.
All right, we've got a pyramid with a square base again. Base side is 16 centimeters. Slant height is 17 centimeters.
Got it.
What's the total surface area?
Okay, base area B is 16 times 16, so 256 square centimeters.
Yep.
And the perimeter P is 16 times 4, which is 64 centimeters.
Exactly.
Slant height L is 17 centimeters.
You're on fire.
So TSA equals B plus 1/2 PL.
Plug in the numbers.
TSA equals 256 plus 1/2 times 64 times 17.
And what's that equal?
1/2 of 64 is 32 times 17 is 544. So 256 plus 544 equals 800 square centimeters.
Yes. Another pyramid conquered.
Feeling like a geometry wizard over here.
Not gonna lie, you're killing it.
But what if things get trickier?
Like what?
Like if we're given the volume and base area but need to find the height?
Ah, classic SAT curveball.
Exactly.
But no worries. We just need to rearrange the formula.
Sounds a bit sketchy, but I'm down.
Trust me, it's not. From V equals 1/3 BH, we solve for H.
So H equals 3V divided by B?
You got it.
Alright. So if the volume is 40 cubic centimeters, and base area is 12 square centimeters,
plug it in.
H equals 3 times 40 divided by 12.
Which simplifies to H equals 10 centimeters.
Dope. That wasn't so bad.
See? Piece of cake.
Okay. But here's a brain teaser.
Oh.
What if the height increases by 20%, but the base edge decreases by 30%?
Oof, that's a spicy one.
How does that affect the volume?
Let's break it down.
Yeah, let's unpack this.
Height becomes 1.2 times the original.
Right.
Base edge becomes 0.7 times the original.
Since the base area is side squared, the new base area is 0.7 squared times the original b.
Exactly.
Which is 0.49 times b.
So the new volume is 1/3 times 0.49 b times 1.2 h.
Crunching the numbers. The volume decreases by about 41%.
Wild, right? Small changes can make a big difference.
Mind blown.
Math is full of surprises.
So we've been talking about pyramids with square bases. What about other shapes?
Good question. It's all about regular versus irregular pyramids.
Spill the tea.
Regular pyramids have bases that are regular polygons. All sides and angles equal.
Makes sense.
Irregular ones are more chaotic.
So with irregular pyramids, things get more complicated?
Yeah, but the principles still apply.
Just a bit more math?
Exactly.
Gotcha. So key takeaways?
Know your formulas, practice like crazy, and don't panic.
Solid advice.
Break problems down step by step.
Also, drawing diagrams helps big time.
Absolutely. Visuals are clutch.
Any final thoughts?
Remember, math isn't just about numbers, it's about understanding the world.
True that.
Pyramids are everywhere.
Keep grinding, fam. You've got this.
Stay woke and keep those brains sharp.
All right, that's a wrap.
Until next time.
Peace out.
Peace out.